Hello and welcome to our video on the distance between 2 points. Now this formula that I've got down here in a box is most useful when you are given 2 points. You might be given 2 points in the plane like this with the coordinates and you need to find the distance between the two. Or you might be given 2 points written like this and 4, 10, just made two up for you, without a graph, but you've just been given the two coordinate points and you need to find the distance between those 2 points. So as a first step, you could graph them, but this formula that I'm about to show you would be really useful to help find the distance really easily. So I'm going to go over here to look at the graph that I provided, and I'm going to make up 2 points. That could be the two that we're looking for. I've made my dots really big just so you can clearly see them, but your dots don't need to be that large. So if we're trying to find this distance on the straight line between the 2 points, we're going to need to know a few things first. We're going to need to know the coordinate point. So this would be this is the y-axis, so this would be the y value of this point, and this would be the y value of this point. So I'm going to call this one y1 and this one y2. And you can see they line up with the 2 points. And I'm going to do the same for the x values. So this is the x-axis. This here would be the x value of this point. And here would be the x value of the second point. So this one is y1, so this one can be x1. And this one can be x2. You can see how they're linked to each other there. If you had the coordinate point written out, this one would be, this point as a coordinate would be written as, we always write x first, so it would be x2 comma y2, and this one here would be x1 comma y1. Actually, I've just decided I'll write that on the other side. X1 comma y1, and you notice the 2's go together and the 1's go together. You would never have an x1 and a y2. It doesn't work properly. Now what we're trying to do is find the distance between these 2 points here. So what I can do now is draw a triangle going across here and up here. And that would be a right angle triangle, and hopefully when you see a right angle triangle you are remembering our famous right angle triangle formula, which is a squared plus b squared equals c squared, Pythagoras' theorem. And what that can do for us is help us to find this third side. So the third side opposite the right angle is called the hypotenuse. You might recall this length is just going to be this number, take away this number. So let's put it in as x2 minus x1. Oops. This length here is going to be the y value y2 minus y1. And if we substitute these in, might give them a different color, so we could make this side A and this side B for our formula up here. So we get actually I'm going to flick those around so the formula works okay. Doesn't matter which one's A and which one's B. This one will be A, this one will be B. So substituting in, we get x2 minus x1 squared for a squared plus b squared, which is y2 minus y1 squared, and it will equal our c squared. And instead of putting c squared, I'm going to put d for the distance. And we've got these two plus, but it's d squared. We don't want to find this side squared, we want to find just d by itself. So to get rid of this squared, we need to do the opposite, which is square root this whole thing. Plus y2 minus y1 squared. Make sure your square root sign goes over all of it. And you get d by itself. So this distance here is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's a formula I've got right down here, and that's the one that you can use to help you find the distance between 2 points. Here's an example below that you might like to have a go at before we go through the solution together. Pause the video now. Okay, hopefully you have had a go at that example. What can be really useful when you're not given a graph, or even if you are given a graph, is to write out the 2 points on the side, or coordinate points, and then underneath just label them as x1, y1, and x2, y2. You could have done it the opposite way. You could have made this x1, y1, this one x2, y2, and you'd get the same solution. So this is just what I've chosen. What you can absolutely never do is put x1 and y2, so a 1 and a 2, together in the same pair, because this formula will not work if you do that. So you need to keep the coordinate points with the same numbers. This is what I've chosen. If you've chosen the opposite, fine, but your solution at the end should be exactly the same. So first up, I'm going to write out the formula that I'm choosing to use. Now I need to substitute the values in. So for x2, I'm going to put 1. Start with the square root and the bracket. 1, take away x1, 0, squared, plus y2, which is 7, take away y1, which is 2, 7 take away 2 squared. Make sure your square root sign goes all the way to the end of the equation. Simplify this. 1 take 0 is 1 squared, plus 7 take 2 is 5 squared. And this is where, if you did the opposite, your numbers should start to look similar to mine. So 1 squared is 1, 5 squared is 25, square root of 26. Now, if you are asked for an answer in exact form, this is the one you give. Just give the square root like this. It's called a surd with a square root on it. Completely fine to leave it like that, just like when we do our Pythagoras problems. If it's a real life problem, or you need it in a decimal approximation, you'll need to use your calculator. And when you do that, you will find that square root of 26 is 5.099 to 3 decimal places. And I'll just put on there, that is the decimal form answer. Thanks for watching the video.